So let's get a few things out of the way. I moved your test back to the 14th. So that's
I
next
think on the 14th,
Wednesday.
I think on the 14th, I got to take the SAT, so I don't know.
That's on the 13th.
Okay.
Yeah. So the reason why I'm making the test on the 14th is that if for some reason you guys waited until the last minute to study for the SAT, right? In order of importance, the SAT is much greater than the physics test, right? So if you're going to choose one thing you're going to study for over the other, you would choose the SAT. Now, is it possible for you to study for 2 exams at once? Definitely possible. But will you guys most likely do that? I do not think so. So instead of trying to compete, obviously, because the importance of the SAT is much greater than just a random physics test. Well, that's not really random, but then again, the SAT is more important than a single physics test. I decided that I would delay the test until after you guys took the SAT, which is Tuesday, right?
We can also retake the SAT in senior year, right?
Yeah, you take the SAT multiple times. Try taking the
Well, like
ACT.
multiple times throughout senior year, or like?
I have no idea, guys. I only took it once. All right. I really don't know. It's
Wait,
been a
what you
long
get?
time
What you
too.
get, sir?
I don't remember. I don't
Is it
remember.
good though?
Probably. I don't. Yeah. I really don't remember, guys. Uh. What was I saying? Oh yeah. Yeah. So obviously, I'm not gonna delude myself. I'm not gonna delude myself into thinking that you're gonna care more about my physics test than the SAT. Okay, that's not. I don't really have that type of delusion. Ah. Yeah. So it's gonna be next Wednesday. All right. So we're gonna continue work energy theorem. All right, we're gonna continue the work energy theorem. Let's continue. What are my notes? This is the last practice problem we need to do.
Your force due to gravity is 6 times 10 squared.
Yes. Force due to gravity is 6 times 10 to the 2 squared. I mean 10 to the 2 newtons, or 10 squared newtons. What are my other notes?
Your average speed of 3.0 meter per second.
Yeah, so my average speed is 3 meters per second.
And your time
So,
is 5 seconds.
and my time is 5 seconds. Oh, perfect. Yes, that is correct. Person who messaged me privately, but I'm waiting for someone to say it publicly. What are we solving for?
Gravitational potential energy.
Okay. How would I write that? Yes. Okay. Yes, that's correct. Brandon and another person who messaged me privately. Yeah. Wait, I'm actually surprised. I really am surprised. So it is delta. It is delta PE. It is delta PE. Now the delta is important because you don't know what height he goes to, right? You don't know the exact height he goes to, but you do know that his height changes as he rides up this elevator. So the final question says, well, how much does this person's gravitational potential energy increase? That's signifying change. How much does your potential energy change? Right? So, which is basically delta PE, which is the proper way of writing it. So you're solving for delta PE. So now we're left with, we want to do the work energy theorem. Work energy theorem. So breaking that down, delta ET is equal to delta PE plus delta KE. And delta, okay. So we got up to this point. Let's get rid of something first. Let's actually solve for one part of this first. What do we do for this one? What do we do for that?
You find your final and initial velocity.
Okay, right? Because we know that delta KE is equal to your final kinetic energy minus initial kinetic energy. And we know that your final kinetic energy is equal to 1/2 mvf squared minus 1/2 mv initial squared. But here's the thing. Here comes the part where you have to make some really educated assumptions. And this is something a student in none of my previous classes has done so far, is to make the correct assumption here about what delta KE is. Let's see if you guys can make that assumption about what my delta KE is. Give you guys some time. Again, guys, do I expect you guys to do it? No, because none of my students from my previous classes has done it. Well, let's think about it, right? Let's. What's my final? What do you think my final velocity is? Do you think when you're reading this problem, does the problem mention like he starts anywhere or stops anywhere? Yes, that is correct. Person who messaged me privately. That is correct. Good job. First person out of all my classes that give me the correct answer without me coaching them. I mean, I didn't want you to spoil the answer, but you just did so. So Brandon says that there is no change in kinetic energy. He says that your kinetic energy is 0. Your change in kinetic energy is 0. Why? Why is my change in kinetic energy 0? Brandon, you're not allowed to answer. Doesn't matter if mass stays the same. Actually, I mean it does. Why do you think my velocity stays the same? Average speed. So because this is like a very brief like regions problem there, it doesn't really get too complicated. You can basically assume that this average speed, right? When you're reading this, his average speed is 3 meters per second for 5 seconds. So you can basically say that for each second, right? For each second in these 5 seconds, his velocity is 3 meters per second. So basically that's saying his initial velocity is 3 meters per second. His final velocity is 3 meters per second. So his velocity doesn't change, it remains constant, right? So if his velocity remains constant here, right? So this is a constant velocity, constant speed. If his speed remains constant, then it doesn't matter because both of these values are the same. So your delta KE is going to be 0. You don't experience a change in kinetic energy. Guys, the problem is not telling you when the person gets off. It's not telling you that the elevator has reached its final destination. It doesn't even tell you where the elevator is starting. It could be in the middle of its trip right now. Now, can you take average speed to mean constant past this class? No. You cannot take average speed b equals constant past this class because average can mean a whole lot of things, right? You can either get 5 threes, you can add up all these threes up and then divide it by 5 and you get 3. Or you can do 4 plus 2 plus 3 plus 3 plus 3 divided by 5 and you get 3. Or you can do 4 plus 2 plus 5 plus 1 plus 3 divided by 5 and you still get 3. So does this work? Can you take the meaning? Can you take, if a problem passed this high school physics class, say, if you take the meaning of average speed to be constant past this high school physics class, you will be incorrect. All right? You will be incorrect. But for simplicity's sake, you can take this to be true. Okay? For simplicity. Just for simplicity. So your kinetic energy doesn't change. You're traveling at this speed for 5 seconds. I'm not going to answer that. That's rude. It's rude to other classes. It's also rude to your class. It's also rude to in general. I don't like doing that. Obviously, yeah, it is rude in general. So you're changing kinetic energy 0. Changing kinetic energy 0. So we're left with work is equal to delta PE. And we want to know what delta PE is. So we have to figure out, how do we solve for work? How are we going to solve for work? This question I'm asking.
We're given force due to gravity, and we're also given a height. We can say 3 meters times 5 seconds is 15 meters he traveled.
Why are you doing 3 times 5?
That's how far you travel, which is the formula for potential energy.
Oh, okay. So you're doing formula for potential energy. That's another way to solve it. Uh, let's do it the work energy theorem way. How do we solve for the work that this elevator does? This elevator has a passenger. The elevator is doing work. How much work does this elevator? How much work does this elevator do?
Force, which is force due to gravity,
Mm-hmm.
and your distance is also 15.
Yep. Yep. So the formula for work is your force applied and the distance that it travels. But you know that your force applied is equal to your force due to gravity, because the elevator is lifting you up. Now, what's D, right? Because we need to solve for D. What's the formula for us to get D here? Jonathan said it. He just told me to multiply two numbers. He didn't tell me how to do it though. He just gave me a multiplication. He just told me 3 times 5 is 15, which is correct. But how is he doing that? Why can he do that? Why is he doing 3 times 5?
Velocity times time is displacement.
Yeah. So this is the first formula you guys have ever learned in this class. Average speed is equal to d over t. The very first formula you guys have ever learned in this class is v bar. V bar is equal to d over t. And when you multiply by t on both sides, you get v bar t is equal to d, which you're going to plug it in over here. So v bar t is equal to delta p. So fg is going to be 6 times 10 to the 2. V bar is 3. T is 5. delta PE. Multiply all this together, you get 9 times 10 to the 3 joules. That's it. So really, this is like a combination of everything you learned. You group work. You learned work in lesson 5.1. We talked about energy in 5.3, 5.4, 5.5. And now in lesson 5.7, we tied all those things together and we learned about the work energy theorem. And you can apply this theorem to pretty much all questions in this class, in this unit. When you do work on an object, you change an object's energy. For you to change an object's energy, you must do work on an object. All right. Any questions? Please raise your hand if you have any questions. Yeah, so it's lesson 5.1. I would check out lesson 5.1 and the answer key for the worksheets because it's really, I think so. Yeah. Thing is, guys, to be honest, if you think about it, the formula for work is literally the same thing as the formula for the potential energy on your reference table. Where do you think this formula comes from? It comes from work, because you know Fg is mg, and you know d is basically change in height anyway. Right. So work is equal to delta PE. It's just another way of doing it, right? It's just another way. I want to talk about your test again. So it occurred to me, oh yeah, this one. Guys, so I attached something that I think might be useful. So this thing right here that I attached to Google Classrooms, this is something I gave my students last year. It was basically every class at the beginning of every class, I had them come up, or rather when they came in through the door, they were to take one of these note-taking sheets where I would basically give them the notes, right? And they would have to fill out parts of the sheet. It was basically an easy way for students to take notes, right? Because it contained all the necessary information, right? It contained prompts, what they needed to write down, stuff like that. It contained vocabulary words they should memorize, right? All the way at the top. So if I ever asked them a question, the vocabulary definitions were all the way at the top. So they didn't have to go flipping through their notes to look for it. They had, when it was time to do practice questions, guess what? I had literally steps written out that they had to answer, right? Step 1, what are your knowns? Step 2, what do you want to find out? Step C, literally just reading off the definition of conservation of energy. Step D, what's the formula? Step E, what's your total energy at the top? Step F, step G, step H. And essentially, I would guide them, right? I would work with students, I would basically guide them through how to answer practice problems. Why am I not doing it this year? Because you guys are remote. So I felt like, so was there any reason for me to do any of this? Because I can't really give you this to do online. I can't check if you're doing it remotely. It's just annoying in general for you guys to do it this way. So I was like, I'm not going to do this year. I'm not going to give my students notes like this year. I think that was kind of a mistake. I think that was kind of a mistake. I think I should have at least given you the template so you could choose whether or not you wanted to use it or not. But better late than never. So if you want to use this to help you study, help you solve questions, because I basically do guide you on how to solve questions. If you want to use these as like to help yourself again, right? If you want to use this note-taking sheet to help yourself, you can. If you don't want to use it, you don't have to use it. Now, let's talk about how to study for a test. I feel like a lot of you guys don't really know how to study for tests. It's, in general, right? Because in general. So how I usually did it is, and this is a very basic studying method. Studying method. For my physics class in university, I would make a mock exam. Take all the possible questions from each topic that was going to be on a test. Put it in an exam. Give myself that exam. I would, any question that I wasn't 100% sure on how to solve, I left it blank. Even if I kind of knew how to do it, but I wasn't 100% sure that I was correct, I left it blank. After I finished my mock test, I would go back, see which topics, the questions I did not answer or got wrong. I would then narrow down the topics I needed to study for down to very, very few topics, which made it easier because I'm not just studying things that I already know how to do. So that's why I'm suggesting you guys do. For example, I already made you guys a practice test. What's number 1 about? Well, that's springs, 5.6. That's lesson 5.6. What's number 6 about? Well, that's lesson 5.2. 7 is 5.2. 8 is 5.2. 9 is 5.2. So for example, if you didn't know how to do question 2, actually, if you didn't know how to do question 1, let's say you didn't know how to do question 1. Instead of guessing, just make a note that you don't know how to do question 1. Then come back, then now you know which topics you need to study for. You need to study topic 5.6. Anyway, but that's a very, very basic study method, guys. Guys, I hope you have a great weekend. I hope you have a great weekend. I will see you guys next week, okay?
Bye.
Bye, guys.
So like you don't take attendance anymore?
I do.
Like automatically? Oh, you just like
I use a Zoom automatically thing.
I see, I see. You stepped it up now, huh?
What are you talking
Have a
about?
good week.
I'm stepping it down. I'm stepping it down. What the hell?
I mean, you're taking it automatically now, though.
Yeah, but that means I'm stepping down. That means anyone that shows up, the Zoom gets marked here.
I know, so it's like, but never mind, never mind.
What?
I get what you mean. I get what you mean now.
Okay, all right. Have a great weekend. Have a good
Yeah,
weekend.
you too.